So I want to start with a real quick review, just a real quick question and answer before we move to homework. I want to review the language and cheats. So, first of all, what does the C in cheat stand for? Connection and conclusion. Why is this the most important of all the cheats? You have to be doing it with every problem. This is what separates standardized math from your classroom math. They expect you to analyze and make connections and conclusions. They expect you to notice if you have an isosceles triangle that the opposite angles will be equal. They expect you to make, if this is true, then this must be true. They expect you to notice, oh, this is a quadratic, I could factor it. Or this is two binomials, I could FOIL, or distribute, expand, if you will. Yeah, you have to be doing this on every question. And don't forget, one of the cheats with the C is peekabooing the answers, comparing and contrasting the answers to see what's similar and what's different. Oftentimes you'll be informed of a potential trap, right? Well, there's a +3 and a -3. Okay, they're telling me that I better be careful with my symbol. Oh, these two equations are exponential and these two are linear. I better watch my language to see is this linear or exponential in the description, right? So constantly be doing the C, that's why that's number one. What does the H in cheat stand for? Which means, give yourself a visual. I read XY coordinate plane, I'm ready to carefully mark my lines and graph whatever they do. I'm ready to give myself, if they say something about a circle and a line, or a triangle and a rectangle, I will draw them out. And then we saw the one about the diner. Remember the problem we did about the diner?
Yeah.
I just gave myself a visual and I could answer this, and nobody knows what the equation looks like, but we can still get the answer, right? Give yourself the visual. The E is estimate, eliminate. Sometimes you can only estimate to narrow down to 2. I'd rather a 50-50 shot than a total guess. So, but some of the hardest problems can be solved with just straight up estimation, and I showed you an example, right? The hexagon and the square. What does the A stand for in cheat? Why is algebra cheat? Why is algebra cheat? And you do algebra, it's not cheating, that's working. Because just do what you know how to do, even if you don't understand the problem. You'll get rewarded, right? Do you know how to distribute? Do it. Why? I don't know yet. You know how to combine line terms? Yeah, I'm going to do that. Do as many steps of algebra as you can, and quite often it reveals itself. They make problems like that on purpose. They make problems like that to look wicked scary, but it's always easy. Remember, have that confidence. The math is always easy. So if you see something that looks scary, what's the easy principle behind this? There's something easy. Well, let me do what I know how to do. And then lastly, your ace in the hole, the T in cheat is, what are the best numbers to test? Answer is depends on the question. Sometimes 100 will be best if it's a percentage. Sometimes the number 33 could work best, depending on the wording. Sometimes when you don't know, then your fallback, now you can tell me. When you don't know what else to test, you test -1, 0, 1, right? I'm ready to test a negative, 0, which is a neutral, and 1, which is a positive. I'm ready to test them all. And I want you to do lazy math. I want you to pick the numbers that make you do the least work. And last but not least, certainly not least, is if you see ordered pairs, plug them in. There's something somewhere. Plug every ordered pair to every equation you see, you will get the answer even if you don't understand what this question's about. All right, watch your language. I'm going to say a word, you tell me what your association is with that word, whether it's an operation you have to do, or what does it mean to you based on having read Watch Your Language. You see the word parallel, what does this mean to you? Same slope. You don't even have to ask questions or wonder, you know that's where they're going. If you see the word perpendicular, negative reciprocal or opposite reciprocal, slope, still. If you see the word each, see the word more, I'm gonna add something to it. If I see the word of, typically multiply, but you have to be careful in case it's used to mean out of, in which case you have to divide. What about infinite solutions? Same line, so therefore, same slope. Same y-intercept could matter too, but start with same slope. If you see, let's see. Okay, I think this is very important too. What if I say there's an increase of this for each of that? What does that cue you in? There's an increase of this for each of that. That's the rate, or in other words, slope, right? You gotta be sensitive to the language. If you see, oh, by the way, what is a solution? Point of intersection. If there's no solution, no intersection. If it's two lines, same slope. Okay. All right. Did you read on the back side also? We'll probably get a little bit into this language today, and we'll continue to reveal as we go throughout, but if you see something about which is the best, which equation reflects constant and coefficient, by the way, what is constant and coefficient? When you see these words, what should you do? You're gonna have your numbers. Don't get confused by it. Which of the following equations, blah, 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 constant coefficient, the x-intercept? X-intercepts. That's code for we want x-intercept form. Blah, 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 constant coefficient, vertex, blah, blah, blah. Oh, vertex, they want vertex form. So those of you who have been in algebra 2 already, here's just a simple equation, x squared plus, oh, what the heck am I doing? Plus 6x plus 8, that's in standard form. And then if I do this, x plus 2, I'm factoring it, x plus 4, that's in factored form, and this would be in vertex form. So I want you to look at this, and you see the words that give you a lot of blah, 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 constant coefficient. It shows the minimum value of the equation. Well, the key word is minimum value, which is shown at the vertex. So that's the right one they want. They're all equal, right? They can show you a graph and say, which one of these represents that graph? And students will pick the wrong one all the time because they're not watching the language. But if you see anything about x-intercept, roots, zeros, solutions, which form? If you see anything about the y-intercept as a constant or coefficient, which form? That's the one that has the y-intercept. Right? So again, they play a lot on this language, and when you see the language, there might be a question in the homework that you might have gotten wrong because of that language. Did you guys check your answers yet? Okay, so I should have mentioned that to you actually. Going forward, just to save us some time, I will ask you to check your answers as well. But you need to be intellectually honest with me to say, all right, I got this one wrong. Oh, I understand what I did wrong conceptually. That's great, but talk to me about it so that we can discuss, was there a way to cheat that one? Because I can't guarantee you on test day you will see the concept to know what to do, right? So we want to be able to hit, even if you understand afterwards, we should still discuss so that we can talk about what are the different ways we could have solved that more easily. All right, so I will read the answers real quickly for you, and you can check them, and then going forward, I'll ask you to do the checking yourself, so that when you come in, it's where we get to discuss the items you got wrong. I know it's a classroom with close to 15 people, but honestly, I want to give you as much individual attention as possible, so you've got to ask me questions if you get something wrong. I want to be able to really help direct you and know how to apply the cheats. So, in section 3, the non-calculator section, let me read the answers. Are we ready? Section 3 of practice test 1. The answers are D, A, C, B. Number 5 is C, A, B. Number 8 is C, B, A, D. Number 12 is also D. 13 is B. 14 is A. 15 is D. And I know we did some of those together, so hopefully you got them right. But if you try to do it on your own and still got it wrong, ask me so we can make sure you know how to attack it. In the part where you bubble in, number 16 should be 2. Number 17 is 1600. Number 18 is 7. Number 19 is 4/5 or 0.8. And number 20 is 100. Let's continue to score section 4. Section 4, number 1, we have B, C, D, C. Number 5 is D, D, C, D. Number 9 is A, B, A, C, C. 14 is also C. 15 is A. 16 is C, B. 18 is A, B. Number 20 is D. 21 is C. 22 is B, B, A. 25 is D, B, C. 28 is C. 29 is D. 30 is D. Number 31, where you bubble in your own answer. Any value between 4 and 6 inclusive. I mean, 4 works, 6 works, and anything in between. So a lot of these you'll get a range of values that are valid. 32 is 107. 33 is 5/8 or 0.625. 34 is 96. 35 is 6. 36 is 3. 37 is 1.02. I did a terrible job with social media. I apologize. I will be more active with social media this week. But I did post that particular, a couple of these problems. Did you notice?
Yeah.
Good. It has to be greater than 1, and I think I missed. Thanks for pointing out.
Yeah, you're welcome.
In fact, I misspoke. I wouldn't put my money in that bank, right, where I'm going to lose money, because if you raise a value less than 1 up to an exponent, you're going to lose money there. Don't put your money in that bank. So it has to be 1.02, and number 38 is 6.11, $6.11. All right. So I'm going to ask you to keep track of how many errors you made, and you might have got a little boost this time because I went through a bunch of these with you initially. So the next math, you might have more errors, I don't know, but over time, your peaks and valleys of your performance, you'll get better and better and better. So if ever on the next one you do worse, don't panic. We're still practicing how to apply the strategies, okay? So, section 3, no calc. First item you want to talk about? Anything from 1 to 4? Anything from 5 to 7?
7.
You're saying 7, right? Okay, so before we talk about number 7, I want you to solve this problem with me first. What does B equal? Well, how do you isolate an algebra? What do you have to do? Yes, some people are only comfortable saying divide by 3/4. Yes, but that's multiply by the reciprocal, right? So we're going to multiply both sides by 4/3. Cancel, say cancels, and we get to do that because there's no pluses or minuses. equals 4/3 A. That's all that's happening here, and they gave you scary math. You're looking at this, you're like, oh, I've never done this kind of math before. What is this? It's easy. Notice if you peekaboo the answers, you'll see all they're asking you to do is to solve for P equals. Oh, I have to solve for P. So I just need to multiply by the reciprocal. Jerks. Scared of it was that easy, right? So the answer is multiply by the reciprocal. Looks scary at the time. Will they give you a problem like that in the future? There's a chance. There's a good chance. So just keep that in mind. Are we okay with number 5? Just thought I'd point out, even if you got it right, number 5?
I got it wrong.
Okay, just thought I'd point out one thing that they hit every test multiple times. You really have to be on, OCD alert. Will you distribute the negative? Will that become a negative a positive x squared y, a negative 3xy squared, and a positive 3y squared? That's what they're testing to see if you'll do it. Because what will happen if you have a positive 3y squared and a negative 3y squared from the first expression? They cancel. You should have no y squareds, right? None of the 3y squareds. So I think C, we can't go with D, it's got to be C, right? The y squareds cancel out. And they will do that on purpose, multiple times. It's a thing. They're constantly checking, will they distribute them negative? Next. Numbers 8 through 12. We covered a bunch of these in class, but did we get number 11? Did everyone get that? We're okay on this page? Let's move forward. Last page, we cheated a little bit here too. We cheated numbers 13 and 14, didn't we?
Yeah.
How about number 15? That's what I thought. Now, a lot of students see something and they pick A. Who picked A? Good for you, that means you saw something, but you got trapped by the enemy because what you saw were the possible values for A and B. And they don't want A or B, they want C. Okay? So how can we solve this one? If you try to test real numbers and stuff, you could be there for quite a while. Let me show you a concept that is, it shows up, I don't say on every test, I would say it shows up on maybe 60–70% of the tests. Notes? Ready for some notes? As you might guess by the heading of the notes, I made up the term. I don't know if it's real or not. This is what I call it, because it makes sense. It's the messy polynomial principle. The messy polynomial principle. Oh, geez. Look at that. Which one was I using? Principle. Messy polynomial principle. Because you got a couple messy polynomials. That's the genius name for the term. If you take a look at this, we're going to cheat with algebra. What do you know how to do with two binomials? You know how to FOIL?
Yeah.
Then why didn't you? Or maybe you did. But you should. Why? We'll find out very quickly. It'll turn out real easy in a moment. But let's start with the original equation. It's ax plus 2 times, help me out, bx plus 7?
Yeah.
And that equals 15x squared plus cx
Yeah.
plus 14?
Yeah.
Okay. So let's FOIL this because we can, and we will be rewarded. So first terms give us what? A dx squared, yes? Ax times 7, 7ax. 2 times bx, 2 times 7, I'm not gonna write that again, if you don't mind. Carry it down. I'm not gonna write the right side over. Now, you've got mixed terms, so you cannot combine the x's. And what you have here is you have a mess. And there's a c involved here as well, so that's another mess. Here's the messy polynomial principle. You ready? Okay. Take a look at all of your x squareds on this side. And all of the x squareds on that side. They are not expressed exactly the same, are they? Okay. So then go to your x's. Look at all of your x's combined on this side. And all of your x's combined on this side. They are not expressed the same either, are they? However, over here, the c, you know, ax squared plus bx plus c, do you know what I mean? A squared plus bx plus c. The c value, the last number value is expressed the same, isn't it? Oh, so here's your messy polynomial principle. If ever you do some math and you get two messy polynomials. Ready? If any one part of my polynomial is equal, then all separate parts are separately and independently equal. You get that? If you find one part equal, then all parts are separately and independently equal. So therefore, immediately I know that a times b equals 15, right? So what are my options? 1 and 15, 15 and 1, 3 and 5, 5 and 3. Oh, they gave me some more info. What is a plus b? 8. So of all of my options, a and b must be 5 and 3, or 3 and 5, right? I don't know which is which. That's why we get two values. But if you picked only one of them, you'll still get the answer. But I know a and b have to be 3 and 5, or 5 and 3. So now let's compare our middle values, and I'll solve for c. 7 times 3 or 5 plus 2 times 5 or 3 x equals cx. Boy, I'm really messing on this board. So, what's 7 times 3? Plus 10. 31x equals c. Therefore, what does c equal? So what could c equal? 31. I would stop my work right now, bubble in D and move on, because that's the only one that has 31 as a value. What is it? 7 times 5 is 35 plus 6. Those are your two possible results, right? So we know that c equals 31 or 41. And that all hinges on taking the initiative to do what you already know how to do, and then you get rewarded with the messy polynomial principle. Hey, these are equal, so therefore I can set these equal and those equal, and I'm golden. It makes sense? Messy polynomial principle, I've seen it, not on every test, but I've seen it on probably more than half. Any questions on the messy polynomial principle? Let's move forward to last page. Anything on the last page? I have a number of things to talk about, even if you don't, but I have a feeling you probably want to talk about some of the things I want to talk about. Yes?
17.
Aaron.
Aaron.
Look at that, we're starting already. Number 17, so we're all cool with 16? Yes. All right, so heading of notes. Similar triangles. Every test, every test, 100% guaranteed hits with similar triangles. It's a concept that they've determined must be tested. What is true about similar triangles? They're going to test you on one of two truths about similar triangles. Truth number one, corresponding sides or parts are proportional. Meaning what? They follow the same ratio. So we find a scale factor. What's the scale factor between the big triangle and the small triangle? That scale factor applies to all sides. That's one thing that they will test on. The other thing that they'll test on focuses on the angles. So this is focusing on lengths. And this is focusing on angle measures. So this would be lengths, linear distance, and this is going to be angle measures. Corresponding angles are, I'm going to freak out geometry teachers and say equal. They want me to say congruent. I will say congruent. I'm just going to be lazy. I'll write it out. Corresponding angles are congruent and the corollary, and therefore all corresponding angle sine, cosine, and tangents are equal. Right? So if you find you have, for example, a triangle A, B, C, and triangle D, E, F. Oh gosh. And you're told that they're similar, figure not showing the scale. And I ask you, and I ask you, what's the, and it's A, B, C, D, E, F, so that these correspond, right? Those vertices correspond. If I ask you, what is the sine of F, you go, well, I'll just find the sine of C, and that'll be the sine of F. Does that make sense? Okay, so one of these two things, every test, file it forward, you're gonna notice it, easy money, all right? So, let's see how that applies to number 17. I should look at this drawing, do my analysis, and go, oh, I have similar triangles. I should see that before I get into the words. How do you know they're similar triangles? Can you prove two angles equal? Yeah, they told you one angle is 70 feet, one angle, or vertical, or opposite angles always equal. Right? Now, going in knowing that they are similar, I carefully label all the sides they give me, and I see that side EB corresponds with side BD. And EB is 1400 and BD is 700. Bless you. So what's the ratio between the big side and the small side? That applies to all sides. So if side DC is 800, the big triangle AE has to be twice as big. It's that simple, and when you see it in future, you'll be like, oh yes, I get to apply that. It's not hard. All corresponding sides will follow the same ratio. Does that make sense? So if you label your, if you read in there and you looked at the information and you correctly labeled all the sides, you go, oh, 2-to-1 ratio. Okay? All, again, every test. Next. Okay, number 18, just to mention, we solved with, you guys comfortable with elimination? Okay, that's how I would solve that one, the easiest. Or substitution, but one of the two. Number 19, note to self, pretty much every test also. Here's the concept. Let me forget that problem for just a moment, and let's create, doesn't matter. Let me create a triangle. A right triangle, that is. What must be true about this? they are complementary, period. Doesn't matter if it's that triangle or if it's this triangle. What's true about angles X and Y? They have to add up to 90. Make sense? Okay. So let's label this side A, B, and C. Let me ask you a question. What is the sine of X? SOHCAHTOA. If we don't know SOHCAHTOA, you gotta go back and you gotta memorize it. Let's see. SOHCAHTOA. If you're having trouble remembering, sine is opposite over cosine is, and tangent is. Let's see if that's true. Okay, so the sine of X is opposite over hypotenuse, which is, of course, A over C here, right? Question, what is the cosine of Y? Adjacent over hypotenuse. What is sine of Y? A over C. What's cosine of X? What truth did we just reveal? In a right triangle or in any two angles that are complementary, if any two angles, they don't even have to be in the same triangle, if any two angles add up to 90, what must be true? The sine of one must equal the cosine of the other. That's a truth, it's a hard truth, it gets hit in every test, file it forward, write it down, memorize it, look for it. One way or another, you're gonna get tested on it. So, if you see this, you must conclude, oh, these angles add up to 90, it's the sine of one equals the cosine of the other thing. If you see the sine of one equals the cosine of the other, like if I tell you this, what must you conclude? They add up to 90. You see that? If I tell you this, you better conclude this. If I tell you that the sine of one equals the cosine of the other, you go, oh, I'm gonna add them up to get 90. Got it? Every test. So, let's take a look at this question. I hope you try to use hieroglyphics. I hope you try to draw out this triangle. We got an angle here, and the sine of X, they told you. They first of all, they told you you have a right triangle. Did you draw a right triangle? Yeah, hieroglyphics, hello. Sine is? Not a trick question.
4.
Opposite over hypotenuse. Now at this point, I want you to go, oh, they gave me a 3, 4, 5 triangle. Why? Because every test will feature at least one, if not 2 or 3, 3, 4, 5 triangles. Why? Because they love it, and they use it all the time. They might not have used 4 and 5, they might have used 8 and 10. And you go, oh, well, that's a 4 to 5 ratio, so this is a 3, 4, 5 triangle. We'll talk more about this. You're going to see 3, 4, 5s on every test. Look for them. And do not do like some of my students when I say, what kind of triangle is this? They go, 3, 4, 5. You didn't check the ratio first. If the ratio works, then yes, it's a 3, 4. Don't assume. Because they will give you non-3, 4, 5 triangles. Did I mention this last week? I saw this on a test too. You got to know your enemy. They're wicked. They labeled this a 5 and this a 3, and a lot of students go, oh, it's 3, 4, 5. Why is that not a 3, 4, 5? Because the hypotenuse has to be the 5. Okay? The hypotenuse can't be shorter than the side. You got this. So that was a trap one to burn all the people who are looking for 3, 4, 5s without thinking. Okay? So that's a no on 3, 4, 5. Okay, now we know that this angle plus this angle, which, I don't know, we'll call it y for now. What did we say about them? Yeah, and so guess what? What does y equal? Oh, look at what these people did. 90 minus x. We're trying to hide in plain sight that we're talking about the complementary angle. by, instead of giving you the other angle, they're just saying 90 minus x, and you must make the connection that that's the other angle. So what's the cosine of the other angle? Well, the sine of that equals the cosine of that. 4/5. Make sense? Every test, they'll hit you from one angle or another, part of the fun. But you're gonna get this question, this concept. Follow up, or are we good? All right. Next. Number 20, do we do the algebra? It's straight algebra, but many students have trouble with it.
Yeah, the.
Okay. Yeah. So the number one most repeated mathematical concept on all standardized math tests is substitution. If I tell you what A equals, I will substitute that in. I will get an answer, I will substitute that in. You know, the farther we go with some of the more advanced questions, it's just standard operation that you have to substitute a value in, do some math, get an answer, then substitute that into the equation, then you do some math, get an answer, substitute that in somewhere else, right? Multiple steps. So let's start off by saying, well, if I know that A equals 5√2, let me just go plug that in. That it's 2 times A, the A is 5√2, right? And we're told that that equals the square root of 2x. So from here, you could potentially make some connections and conclusions and see something and know the answer. But if you don't, let's do the next step of algebra. What do we do here? I hear students say all the time accidentally, say, distribute the 2. Like, no. It's not distribute. You only distribute if there's a plus or minus in between. So what are we gonna do? Just multiply and you get 10√2, right? Now, if you examine this, at this point, a lot of students will say, oh, this has got a square root of 2, that's got a square root of 2, the square root of 100 is 10, x is 100. Next question, if you see it, right? If I'm making my connections and conclusions at this stage, you might just see, oh, that has to be 100. If not, let's follow up with the algebra. How do I isolate the variable? By performing the opposite operation to both sides. The opposite operation of square root is there. They cancel, and I get 2x. Now, if you do this, you must square everything inside. I must square the 10 to get 100, and I must square the square root to get 2. At this step, you might notice. But those who are crunching algebra don't notice. They just keep going, and they go, okay, well, 200 equals 2x, and then divide by 2, and I did more work than I had to if I was being lazy and making connections, but I still got the answer. Okay? And that's the algebra behind it. Let's keep plowing forward, and now, okay, here's my deal on section 4, calculus. I'm gonna say something to irritate you, and then I'll let go. You should have nothing wrong before number 20. Anything before number 20 should be easy. If you have any errors before number 20, it's because you misread or you made a noose. A few rare exceptions. But you'll see anything that you want, if you want to talk about numbers 1, 2, 3, 4, 5, 6, all the way to 19, I'll talk about all of them. And with but you're going to see that the math, it's always very easy, and you should go into it with that mindset. This should be easy. If I'm not catching something, go answer all the other math questions you can, and then come back. And then sometimes, having done other math, something will click. Okay, so that's test-taking strategy you want to consider. But you got to know everything up to 20 is easy. Like I said, in the upper teens, occasionally there's something you have to do that will trip you up because you're just not comfortable with the wording maybe, but it's a misread or an oops, and I'll prove it. So let's talk about all of your errors up to 20, and you're going to find it's misreads or oops. First item. A lot of students trip up on number 5 because they're not sure about the language. What's a negative association? That's negative slope. Anything else up to number 6? 7 or 8? 8, some students kind of get scared by this, but what would be our great way to cheat this? Oh, well, which one of these works? Let me see. These idiots gave me the answer. I will test 0, that no work. I will test 1, that no work. I will test 2, that no work. Answer's D. Anything from 9 to 14, anything in here? We're all good? Excellent. You sure? Okay.
Wait, which number?
Anything between 9 and 14. I get mistakes in here all the time, so there's nothing to be embarrassed about. If you don't want to ask me now, you could ask me later, I suppose. Off the record. But honestly, let's start. This is where we make improvements. Okay? Let's move forward. I also put I also put this chart as a snap tip, if you saw it. One of their favorite traps is to give you different X values versus Y values. You see that? And so, when we get to number 16, a lot of students will pick B because they did a rise of 3 and a run of 4. And it looks like a slope of 3/4, right? Except, what is the slope of this line? It's a rise of 3, and when we go over 4 lines, the X value tells us it's only 1. So it's really 3 over 1. That's why it's 16 is C. It's a nasty little trap they throw. Note to self, always check your X increments and your Y increments, okay? And 15 was a simple language, right? What is the X, or excuse me, what does the Y intercept represent again? In this case, it's the C intercept. It's the starting amount, right? The initial cost. Easy language. Anything 17, 18, 19? Okay. Number 20. Anything 20, you guys all got 20 right? You didn't.
No, I didn't.
Sorry?
I was stuck on.
Okay, so this is a good one to talk about. I told my student that I was gonna keep referring to him forever because he's a really great math student, and this year he graduates as a mechanical engineer from Penn State, so he's really, he had like a 780 on the math, and I teased him like, you suck, you get a perfect score because he was that smart. Anyway, he got this one wrong in our training. Because this is your enemy. I'm gonna tell you a story going forward. Right? You're gonna get this much of a discount, and then you're gonna pay this much tax, and then you're gonna get this value. But I'm gonna ask you to do the math backwards. So he saw the relationship. How many of you picked C? Good, that means you saw the relationship. But that means you don't know your enemy yet, because you're gonna have to do the math backwards. The story they told you was in order to get P. But they don't want P. They want O, original. They don't want the purchase price, they want the original, so you have to work your way back to the original. And so this can get a little tricky. So I would just say, and as I told my student, the other student I was telling you about, I said, just cheat. What do you want the computer to cost? 100. So here's my original price. I'm calling it 100 because I can. So there, I get you. You need to have that added. I get it. So I get a 20% discount. What's my discounted price? Discount price. If I get 20% off, now how much is it? 8. Here's a real difficult concept for New Hampshire students. Sales tax? It's not fair to ask that in New Hampshire, okay? 8%, what are we in, New York City, 8%? No, in New York City, I can say 9. 8% tax on top of this. What's 8% of 80? It's the calculator section, use the tool. What's 8% of 80? Well, what's 8 times 8? Slides a decimal, $6.40. Now, what's the final purchase price, which they call P? What's the final purchase price? 86.4. So when O is 100, P is 86.4. Give me any equation, I'll solve. Oh, they want me to put P. Grab your calculator. What's 0.88 times this? Not 100. What's what's 86.4 divided by 0.88? Not 100. What's 0.8 times 1.8 times this? Not 100. Circle D, move on with your life. Does that make sense? Having said that, I want you to watch one last little dastardly trap of the enemy. Look at how they have put how they worded D. They put P, which I'll put in 86.4, over, how do they put this? Parentheses, what's in the first parentheses? And what's in the second parentheses? If you plug this into your calculator precisely as you see this, the calculator is not going to give you 100, which is what we need. Because the calculator is stupid. Why 86.4 divided by 0.8, I take that value and multiply it times 1.04. Idiot calculator. I have to tell you everything? I better put parentheses around that, otherwise I'm not going to get it right. Okay? Just one last little trap, because they know the calculator, the way calculator thinks of PEMDAS, and it'll get a value and multiply if you're not careful. Okay. Any other clarification? Go forward. 21. Just make sure you read the right columns out of the right row. Notice that they say at least one dream, which means you've got 2 columns. It's the 1 to 4 and 5 or more. Yeah, gotta make sure. 22, 23. Data. 22. So the language says at rate of change. That means rate is per year. So how do I get that? I get total change, right? Per 2, because it's 2 years. So what is the total change from 358, 704 or 708 to 488, 106? What's the total change for agriculture? What's the total change? Okay, divided by 2. Oh, that's after divided. Okay, good, you're ahead. So whatever the change is, I'm not thinking. Divided by 2, you get 64 something or other. The answer is B. How many of you are messed up by I don't have enough zeros? Read what it says underneath, because this is pretty common with large number data. Underneath it says that the numbers given above are in thousands because we're trying to save space on all the zeros. So once you get your answer, just put 3 zeros and there's your 65 million. They do that a lot with large number data, you know. This is in thousands. So be prepared to read that properly. 358,000. In other words, 358 million. very common on their data. Next. "24. If you pretend that you all got 24 right, I'm not gonna trust you. Let me tell 24. Okay. All right, let me give you my spiel on, excuse me, next set of notes, you should jot this down. Because this is also a very popular concept, it's on almost every test. I've seen a couple of tests without the circle equation, but not many. All right, so I'm gonna make a bold statement. Circles are triangles. Circles are triangles, did you know that? You don't believe me? I'll prove it to you twice. Circles are triangles. Circles, right now, circles are triangles. All right, how many of you are in pre-calc? Have you done the unit circle yet? I'm just like incredulous. That's just me. Okay. They have, your teacher has a methodology. I just give the unit circle on day one. But here we go. Here's the circle. It's in the coordinate plane. Yeah, that comes worse. Okay. And in this, with the center at the origin, right? What is true about a circle? There's a radius. What are you observing here? Circles are nothing more than an infinite series of right triangles in progression. There's the visual proof. Circles are triangles. Infinite series of right triangles, all with the same hypotenuse length, right? Circles are triangles. Now let's prove it algebraically. What did Mr. Pythagoras teach us about right triangles? Yep, a squared. Okay. A squared plus b squared equals c squared, right? Let's draw a triangle here. But since we're in the XY coordinate plane, right? We're in the XY coordinate plane. Let's not use A and B. What would this side of my triangle be called? Instead of A, let's call it the X value, right? Instead of B, let's call this the Y value. Instead of C, what part of the circle does this represent? Radius. Guess what the equation of a circle is? Does this look familiar? Circles are triangles. If ever you get any question involving a circle, we're going to use what we know about the standard form of a circle equation, and we're going to use triangles. Anytime you see a circle, you go, oh, triangles. I might have to cut triangles here to help me. But this one will be wicked easy. So, there's your circle with the center at the origin. Let's move the origin. Let's move the center. Let's move, let's go 1, 2, 3, 1, 2, 3, 4. Let's move over here to the center at 3, -4. Let's put the center there. Let's give it a radius of 3. So here's my new circle with a center at 3, -4. And a radius of a length of 3. Here's your equation. It's x squared plus y squared equals my radius squared. But I moved my center. When my center was here at origin, these values would be zeros, and that's why this is the base equation. But since I moved my center, I have to put my center in here. Parentheses are the land of opposites. Parentheses are what? The land of, remember that. Parentheses are the land of opposites. So if my center is at 3, -4, what do you think I'm putting in here? Make sense? So if you looked at this equation, you would say, well, let me just square this to get 9, right? If you looked at this equation, you go, well, the center is at 3, -4, and it has a radius of 3, because it's a square root of that will be the radius. So you should be able to look at the base equation of a circle and know where it's located and what it looks like. Similarly, you should be able to look at a graph and know what the equation looks like, okay? So starting with the basic equation of a circle, which is really a triangle, well, triangle is. I read this. Which of the following equations of a circle, equations of a circle, this is gonna be easy. In an xy plane with the center at 0, 4, and the radius with endpoint 4/3, 5. Well, they gave me an ordered pair. I could go that route if I need to as well. Too much work. I'd rather look at my equations and go, well, I have to immediately get rid of B and D. Why? Because parentheses is the land of opposites, and they told me the y value was 4, so I need to put in -4. So it has to be A or C, right? Easy. It's gotta be A or C. Then I compare and contrast the values that they gave me. 25/9 or 5/3, and they go, obviously it's A, because why? Because it must equal the radius squared. Duh, it's A. I don't have to do any work. And that's how easy that is when we know that, when we know this stuff. If you get an equation of a circle, apply these simple truths, and it's that easy. I don't do any work, I just recognize that it's A. Worst case scenario, you could have plugged your ordered pair in to see if it worked, and you would have gotten lucky because A worked. Did anyone cheat it that way? Who got it right? How'd you get it right?
I knew that from the distance that endpoint is the radius, so I found the distance.
Distance formula?
And then, maybe like the distance.
Okay. Okay, good. So, I mean, that's applying what you knew to the problem, and that's fantastic. But now you can see with this added information, you didn't even have to do that work. And as a fan of lazy math, I'd rather solve it lazily with less work. But if I don't see it, you apply what you knew. Excellent. Are we clear? Circles are. Yeah, thanks for your participation, appreciate it. All right, let's move forward. Anything else on this page? 25, 26, and 27. How many years in that? 25? Okay. First thing, observation. What do you observe about this before you get into the equation, before you get into the words?
Factor it,
I could factor it. Absolutely. I could factor out the -4.19. Well, that's not precise, but I could use estimations. Right? Okay, I could factor it out, excellent. This is an upside down quadratic, is another observation I made. And I read, and it says h is height, and I go, oh my, in an upside down quadratic, I've seen stuff like this in my math class where that's where something hits the ground, right? Okay, so my x-intercepts will be, my starting point when the height is 0, and the end point will be where the height is 0. If you don't catch that, you might not get this, but hopefully you said 0 equals. And then let's estimate and factor out. I'm going to factor out a -4.9 x times what? X, that's an X, trust me. An X minus 5 point something. And I already know that my zeros will be 0 and 5 point something. The answer is A. I mean, excuse me, did I say A? I meant D. The answer's gotta be D because it's actually gonna be more than 5 seconds. So the closest of these is gonna be 5. I love that you thought to factor out. That's very important. A lot of students don't think to factor out when you have a binomial. It's like if you have this, x squared plus 6x, and a lot of students, you're used to doing the quadratic, and they go, where's the c value? I don't know how to factor this. Yeah, you do, it's even simpler. Just factor out a simple x, right? And then your x-intercepts would be 0 and -6. Okay? Yeah, I love that. Think to factor out even when you have a binomial, and then we can use estimation from there. And I don't even have to do any work. If you think to factor out, I don't have to do any work beyond this. It is going to be 5 point something. Although if you have your calculator, find out what it is. So clearly it would take more than 5 seconds. Next.
It's 10.
It's 10, thanks for the heads up.
10:03 actually.
All right, well, we'll wrap up here real quick. We'll go over a little bit, and then our next section will be a little bit short. Yes? 27, I bet you picked B. That's because you don't know the end. You did the math, you got 1,500. You don't want 1,500. What did you solve for? You solved for how many worms would be in those 10 square meters. Is that what they asked for? Probably not. And what's my warning? Oh, look at my answers. They're all off by a factor of 10, yes?
Yeah.
So what should I be worried about? A factor of 10. Okay, I got 1,500. What did they ask me for? Read the actual question. I mean, remember, bookworms, where? Where? Entire field, which is more than 10 square meters, it's 100 square meters. So you just have to multiply by 10. Right? It's the misdirection. It's like, you see this, you got, pow, we want something else. They do that all the time. So, how do we avoid getting that kind of an enemy trap? Read the question one more time after your work. You get so into doing the math, sometimes I did math and I got an answer. Oh, they offered me that. You're gonna get burnt enough times, you're gonna go, yeah, okay, I've been burnt before, let me reread the question. I have one more step. That's classic. Next. Did we do okay with 26? Really? Okay. I'm gonna give something on 26 anyway because it's one of their favorite misdirections. All right, I'm gonna write something on the board here. Forget 26 for a moment. And answer my question as quickly as you can without thinking, just in thinking. Which is greater, X or Y? Isn't that your instinct? Because you see a bigger number with it, which is why it's smaller. Because I only need 2 of these to get 3 of those. I have to have a third one of these because Y is small. That little truth they play on a lot. So, note to self, write this down in your notes. If smaller coefficient means that variable is bigger. A bigger coefficient means that variable is smaller. Smaller coefficient means, this is an equation statement, of course. If you have a smaller coefficient, then the variable is actually bigger. If you have a bigger coefficient, that variable would be smaller. So now let's apply that concept to number 26. Stella? You?
Me? I
Stella?
don't know.
You're not Stella. I was gonna say, I was confused because I didn't think you were Stella. Oh my thought I had the names, look at me. Time. Wait.
Oh my god, this is so
Wait a minute. I had the last name connected better. Okay. It's Christina, right?
Yes.
Look at that. I had you more connected with your last name than that. Little memory games. So I have A and pear tree A and pear tree B, right? Which one produces more, A or B?
A.
So A is bigger, so A needs the smaller coefficient. So let's give him a coefficient of 1, which means I don't have to write anything. And this better be bigger than 1, right? How much bigger than 1? According to the wording. How much bigger than 1? How much bigger is A than B? 20% more. So how do I show 20% more than 1? Put the 0 if you want. Solve. What is A? What did it tell you A? Produces how much?
140.
Right? So that little trick, I've seen this trick over and over in different tests in different ways, so just keep that in mind, that the bigger coefficient means the value is actually smaller. Okay, next. Page numbers 28, 29, 30. Let's talk about 30. How many missed 30? Did we talk about 30? We mentioned 30 last week, too. So were you guys, how many of you picked A for number 30? Be honest. Nobody picked A? But A equals the equation above. What's the correct answer? All because of the key vocab word, vertex, and that's the only one that's in vertex form. Okay? Now A, if you boiled it out, equals the equation above, and kids pick that all day long because they're not aware of the language traps all the time. But if you see the word vertex, or if you see the word minimum value, well, that's at the vertex. Or potentially maximum value if it's an inverted. Those are all code for give me the vertex form. Okay? Number 28, let me make clear that in a system of lines, you must obey both lines at all times. So if you take that first line and you just graph it in using hieroglyphics, it's y equals yes, is equal or greater than, equal to or greater than 2x plus 1. So here's my y-intercept. There's 1 point on my line, and then it's a rise of 2 and a run of 1. There's another point on my, I just being lazy counting. And so here's a sketch of my line. I already know, since it has to be greater, this line has already precluded or eliminated quadrant 4, cannot be a part of the system. Because when you graph in the other line, it's a dotted line because it's not equal. It's at crossing here -1, and it's a rise of 1 and a run of 2. Right? It seems to allow for this part of quadrant 4, but the system does not. The system does not allow for all of this that this line allows for. The system does not allow for all of this that this line allows for. Here's what the system allows for. Follow the line, boom, follow the line, follow the line. Make sense? So if you just sketch the first line, you go, oh, well, he's up. Quadrant 4. Next. And the last, I'm going to take a break here quick. In number 36, what is the key vocab word? Which means set the denominator equal to 0, and then go solve. Do the math you know how to do. FOIL, distribute, combine like terms, get a new quadratic, factor it, x minus 3. If you want to see that, I'll be happy to show it to you during the break, which starts tomorrow.